Hello everyone, today we will talk about how to create a soil salinity map using Easymeter data in ArcGIS. To do that, we need to first have soil samples and our study area, and we need to have an Excel file here which contains Easymeter data for each soil sample. So we have totally 163 soil samples in our study area, and to create a soil salinity map we will use interpolation methods, and now I'm going to give you quick information about interpolation methods. Interpolation predicts values for cells in a raster from a limited number of sample data points, and it can be used to predict values at unknown locations. And here in ArcGIS we are going to use inverse distance weighting interpolation method. In other words, we call it IDW, that estimates unknown values with specifying search distance, closest points, power settings, and barriers. IDW interpolation is a mathematical deterministic, assuming closer values are more related than further values with its function. Here first we need to check the spatial analysis here, that should be enabled, and we should go to spatial analysis tools in Arc Toolbox and open interpolation toolset and double click IDW. And before that we need to join the Excel file data to soil samples attribute table because it doesn't contain the data. To do that, we'll right click and go to joins and relatives and click join. And here the matching attribute field should be FID, which are available in the two data, and we'll click validate join and click OK. And if you open the attribute table of the soil samples, the Easymeter data has been successfully added to the soil samples dataset. And after that we can open IDW, and here soil samples dataset can be inserted, and that value field should be our Easymeter data, and you can rename and show the save folder in your computer, and you can optionally change the cell size. For example, I'm going to put 30 here because it gives me an opportunity to calculate the areas of each soil sample levels easily. And here power can be in a range between 0 to 3, and if you decrease this value to 1, the influence of surrounding points will be decreased, and if you increase the value to 3, the influence of surrounding points will be increased as well. And here you can change the number of points, and you can put maximum distance. And here input barrier polyline means a polyline dataset that can represent cliff, ridge, or some other interruption in a landscape that is used to be a limit or break in searching for input sample points. And you should go to environments and click processing extent, and extent should be the same as layer your study area, and you should go to raster analysis, and your mask should be this study area as well, and click OK and OK. So here is our output dataset, and here we can see in Easymeter data table here the different ranges for different soil salinity levels, and we have totally 5 classes. That's why here in symbology tab we should change the classes to 5, and we need to insert these value intervals in break values of classify here. For example, 2, and here 4, and 8, and 16, and this can be 20 because we cannot see values bigger than 20. So click OK, and you can change the color and click OK. And here is our output data. If you want to calculate the area of each soil salinity level, if we open the attribute table, it doesn't exist because we should reclassify it. To do that, we should go to reclass and open reclassify and insert the output dataset and go to environments, and extent should be your study area, and go to raster analysis, and mask should be this study area too. Click OK and OK. And here we can change the data type to classify and put it here 5 classes, and here you can rename, for example, non-saline, very slight saline, here slight saline, here moderate, and the last one is going to be strong saline. And you can change the color for the output and click OK. And here, if we go to properties and open source tab, we can see that the cell size 30 by 30, and we can add a new field, name it area, and data type should be double, and OK. And we should go to field calculator and press count here and multiply 30 by 30 meters means 900, and take brackets and divide by 10,000 to show the area in hectares, and press OK. And here you can see the areas for each type of soil salinity level, and we can see that the largest one is accounted for slight saline, and the least is for non-saline. If you liked the video, press like and subscribe the channel. Thanks for watching.